Hello guys, welcome back to another video. Myself Pulkit Kumar Yadav from Sri Venkateswara College of Engineering. Today I'm gonna discuss a topic in microcontroller and embedded systems. So it goes like that. So the contents what we gonna see and cover. First one is what is data processing instructions, types of data instructions, arithmetic instructions, move instructions, multiply instruction. So first of all, what is data processing instructions? The data processing instructions manipulate data within registers. They are move instructions, arithmetic instructions, logical instructions, comparison instructions, and multiply instructions. Most data processing instructions can process one of their operands using the barrel shifter. Data processing instructions typically operate on fixed size units of data, such as bytes, half words, words, or double words. They may operate on scalar values where a single data item is processed at a time, or on vector values where multiple data items are processed simultaneously using SIMD, single instruction multiple data instructions. If you use the S suffix on a data processing instruction, then it updates the flags in the CPSR. Move and logical operations update the carry flag C, negative flag N, and zero flag Z. The carry flag is set from the result of the barrel shift as the last bit shifted out. The N flag is set to bit 31 of the result. The Z flag is set if the result is 0. Now coming on to the types of data processing instructions. First one is arithmetic instruction, comparison instruction, logical instruction, move instruction, and multiply instruction. So first one is arithmetic instruction. Arithmetic instructions are a type of data processing instructions that perform mathematical operations on numeric data. These instructions manipulate numerical values stored in registers or memory locations and can perform operations like addition, subtraction, multiplication, and division. Here are some common arithmetic instructions. First one is ADD. This instruction adds two values together and stores the result in a destination register. Example, ADD R1, R2, R3 is add the values in R2 and R3 and store the result in the register R1. This instruction adds the values in registers R2 and R3, stores the result in register R1. Now coming on to the move instruction. Move instruction is the simplest ARM instruction. It copies N into a destination register which is known as RD. Then where N is a register or immediate value. This instruction is useful for setting initial values and transferring data between registers. The general syntax of move instruction in ARM assembly language is as follows. Move in destination source. In addition to it, it copies N into a destination register RD, where N is a register or immediate value. This instruction is useful for setting initial values and transferring data between registers. Now we have the syntax of it as instruction condition as RD, N. Move we use for move a 32-bit value into a register. Then we have MV and move the NOT of the 32-bit value into a register RD. And now we have comparison instructions. The comparison instructions are used to compare or test a register with a 32-bit value. They update a CPSR flag bits according to the result, but do not affect other registers. After the bits have been set, the information can then be used to change program flow by using conditional execution. You do not need to apply the S suffix for comparison instructions to update the flags. We have the syntax as instruction, then condition, rn, comma, n. Then we have some of its functions as cmn refers to compare negated, then cmp as compare tq, which is test for equality of two 32-bit values. Then we have tst, test hits of a 32-bit value. Now we have the logical instructions. Logical instructions perform bitwise logical operations on two source registers. The syntax is as instruction condition srd, rn, n, in which we have its various functions like and operator, logical bitwise and of two 32-bit values. Then we have ORR, logical bitwise OR of two 32-bit values. Then we have EOR, logical exclusive OR of two 32-bit values. Then we have BIC, logical bit clear and not. And we have multiply instruction in microcontrollers and embedded systems. The multiply instruction is a crucial arithmetic operation supported by the processor's instruction set. However, the specific implementation and availability of the multiply instructions can vary between different microcontroller architectures. Some microcontrollers have dedicated hardware support for multiplication, while others may require software-based implementations. Here are some common scenarios for the multiply instruction in microcontrollers and embedded systems. First one is hardware multiplier. Many modern microcontrollers come equipped with hardware support for multiplication. These microcontrollers often include a dedicated hardware multiplier unit that can efficiently perform multiplication operations on binary or integer data. Then we have software-based multiplication in some microcontrollers, especially those with limited hardware resources. The multiply instruction might not be directly available in the instruction set. In such cases, multiplication can be achieved through a series of simpler instructions, such as addition and shift operations, to simulate the multiplication behavior. Now we have the X operators as MLA, which gives them multiply and accumulate. Then we have MUL, which is referred as multiply. Thank you guys for being with me till the end. Hope you like it.